Hello everyone, and welcome back to Destin Learning. In this video, we're going to look at software containerization. This technique has revolutionized how software is being developed and deployed. We will look at some definitions of containers as well as some popular tools that are on the market today. Let's go ahead and take a look. Software containerization packages an application with its dependencies into a container. This ensures consistent performance across environments, making it portable and reliable. Containers offer faster deployment, less overhead, and easy scalability. They are essential in cloud computing, DevOps, and microservices due to their efficiency and scalability. Software containerization offers key benefits such as portability. Containers package all necessary components for an application, ensuring consistent behavior across various environments. This makes them ideal for cloud-native applications and allows seamless movement of workloads between different infrastructures. Containers are efficient because they are lightweight, share the host OS kernel, enable faster application startup, and improve resource utilization. Containers are perfect for horizontal scaling. They can be easily replicated to manage more load. Tools like Kubernetes automate scaling and management, ensuring high availability and resilience. Original content? 3. Scalability containers are ideal for scaling applications horizontally. You can easily replicate containers to handle more load. And container orchestration tools like Kubernetes automate the scaling and management of containerized applications, ensuring high availability and resilience. Containers allow developers to replicate the production environment on their local machines, ensuring consistency across development, testing, and production. This minimizes the "it works on my machine" problem, as the application runs the same way in all environments. Containers allow for faster deployment and updates by enabling developers to replace or update individual containers without affecting other components. This is especially useful in microservices architectures. Containers provide isolation for applications, ensuring that changes or issues within one container do not affect others. This isolation makes it easier to troubleshoot and update applications without impacting the entire system. Several tools have become industry standards in software containerization. Docker is the most widely used container platform, simplifying the process of creating, managing, and deploying containers. It has a vast ecosystem of tools, including Docker Compose for multi-container applications and Docker Hub for sharing and distributing container images. Kubernetes is an open-source platform developed by Google. It automates deployment, scaling, and management of containerized applications, becoming the standard for container orchestration. It handles large-scale applications across multiple nodes and environments. Podman is an open-source container engine compatible with Docker. It operates without a central daemon and offers enhanced security models, such as rootless containers, making it a secure option for developers. Red Hat OpenShift is an enterprise-grade container orchestration platform based on Kubernetes. It includes developer tools, security features, and management capabilities, making it ideal for enterprise environments. LXC is a low-level container technology that provides lightweight virtualization. It offers full operating system containers, similar to Docker, but is designed for experienced developers seeking greater control over their containerization. Containers and virtual machines both provide isolated environments for running applications. Containers share the host OS kernel, making them lightweight and efficient. VMs virtualize the entire OS and hardware, making them heavier and more resource-intensive. Containers share the host OS, start up almost instantly, and use fewer resources, allowing more containers to run on a single machine. VMs, on the other hand, take longer to start, need to boot their own OS, and consume more CPU, memory, and disk resources. Containers offer process-level isolation but share the same OS kernel, which can pose security risks. VMs, on the other hand, provide full isolation with separate kernels, making them more secure but with higher performance and overhead costs. Containers are ideal for microservices, CI/CD pipelines, and cloud-native applications due to their scalability and lightweight deployment. VMs are better for full OS isolation, legacy applications, and full virtualized infrastructure. In summary, software containerization has revolutionized application development by providing lightweight, portable, and efficient environments. Leading tools like Docker, Kubernetes, and OpenShift enable adoption at scale, reducing costs and improving efficiency. Containers offer better resource utilization, faster startup times, and easier scalability compared to traditional VMs. Understanding the differences helps in choosing the right tool. That's all for this video. If you'd like this video, please click the thumbs up button. If you'd like to see more videos like this, please consider subscribing to our channel. That's all for now. I'll see you in another video soon.